See, till now we have seen various solutions like lock variable, turn variable, TSL, Peterson's. All the solutions have one common disadvantage. Or let's forget about lock variable and turn variable. They are out of race. Peterson's solution and TSL, these two are perfect. I mean, they are better. They are good, right? They are working. But the problem with these two solutions is whenever you implement any synchronization mechanisms, they have this problem of busy waiting, which means whenever the entry section it doesn't allow you to get into the critical section, then what the process are doing is they are following an infinite loop in the entry section itself, right? And because of which the time that has been allocated by the scheduler for the process to run on the CPU, that complete time is wasted. The reason is CPU will continuously execute it because it doesn't understand that the process is doing nothing, but the process will continuously be in the loop, right? That is called busy waiting, right? And that is completely a waste of time, first thing. And second thing is, moreover, this might lead to a problem of priority inversion. What priority inversion is? If a process with high priority is inside the it has not yet come, and if a process with low priority is inside the critical section, I already told you this if you remember it. See this, assume that there is the entry section and there is critical section and there is exit here, okay? And now a process with priority low priority L is inside the critical section, it is here, right? And suddenly a process with high priority came into the system, therefore this process will be scheduled first and this process will be preempted. And when this process gets preempted, the process with low priority which got preempted, and the process with high priority, when it enters the entry section, this high priority process will fall in the infinite loop at the entry section, and the low priority process will not leave the critical section because it never gets a chance, right? Therefore both of them will get struck. High priority process will get stuck in the entry section, and low priority process which is already there in the critical section will never get a chance to execute, right? Therefore it is called as priority inversion problem, and this problem is possible in all the solutions which we have discussed till now, whatever it is, either Peterson or all of them, the process with busy waiting, right? Then what is the other solution is, it is like this. If you go to that example that I have been talking about, the one with dressing room, that trial room example, if one person is already in the trial room, right, other person is seeing that the other person is in the trial room, fine, he shouldn't have disturbed him, but this other person will continuously be knocking on the door, right, saying that I want to get inside, and the other person, the one who is inside it, he will not come out, and the outside people, they will be continuously be knocking, right? And that is the problem. Now what is the solution for that? Instead of continuously knocking the door, why don't you go and sleep, so that the process which comes outside the trial room, he will come outside and he will come to you and he will wake up, isn't it? That is a better solution, right? So it is called as sleep and wake up, right? It is also nothing but mutual exclusion is provided without busy waiting. Now we are going to look at some solutions where busy waiting is not there. Simply one process, if it sees that other process is in the critical section, the process will go and sleep, and the process which comes out of the critical section should go and wake up one process and again send it to the critical section. This way CPU will never get blocked, first thing. I mean CPU will never get what can I say, idle, first thing. And second thing is the priority inversion problem will never occur. The reason is, whenever any process with a lower priority is in the critical section, right, that will be pulled out and that will be kept to sleep, right, and then the higher priority process can obviously get inside, right? So now using this procedure we can solve the priority inversion problem as well as the CPU wastage, right? So for that we are going to see something called as sleep and wake up. Sleep means if any process wants a resource or critical section, and if it is not available, that process will go and sleep, and as soon as the other process which is using critical section finishes its usage, it is going to go and wake up the one which is sleeping. So using sleep and wake up we can solve the problem of CPU wastage, right? This is the best method possible, and let's see with examples. Okay, I'll show you with examples how it works.